And 36 is multiplying and dividing integers and multiplying and dividing terms. And the only trick with multiplying and dividing integers is you divide them like regular numbers and ignore the sign. And then you divide, or then if the two numbers that you're multiplying or dividing have the same sign, your answer is positive. If they have different signs, your answer is negative. And we'll look more into multiplying and dividing terms on the problems that apply. A water company charges $1 and 8.1 cents for each 100 cubic feet of water used. If one customer uses 70 of water, how much will the water company charge the customer? So what we need to do is we say 1.081 per 1 CCF times 70 CCF. That'll cancel out the CCFs. And what that shows us is that we need to multiply 1.081 and 70. So for now we ignore the decimal point, and 70 times 1 is 7, 7 times 8 is 56, 7 times 0 is 0, plus 5 is 5, and 7 times 1 is 7. And then we ignored 1, 2, 3 decimal places, so we moved the decimal place 3 places. So $76.67. Each box of cards contains 45 packs. Each pack contains 8 cards. How many cards are in 2 boxes? So 45 packs per 1 box times 8 cards per 1 pack. So the packs cancel. And then 2 boxes. Boxes cancel, and we're left with just cards. So they're asking how many cards. That's good. So what that shows us is that we have 45 times 8. 45 times 8 times 2. So I'm going to rearrange this so it's easier. I'm going to do 45 times 2 times 8. Commutative property tells me I can do that. 45 times 2 is 90. And then 90 times 8 is 72 with a 0 at the end. So 720 cards are in 2 boxes. Doug read 3 books that averaged 156 pages each. He also read 12 short stories that were each 6 pages long. How many pages did Doug read altogether? So 3 books, 156 pages each, plus 12 short stories times 6 pages each. So we need to know what 3 times 156 is. 6 times 3 is 18. 3 times 5 is 15, plus 1 is 16. 3 times 1 is 3, plus 1 is 4. So 468. And then 12 times 6 is 72. So 540 pages altogether. A bank prefers to have a customer to teller ratio of 3 to 1. If there are 9 customers in the bank, how many tellers should be available? So this is a proportion problem. So we have a ratio of customers to tellers, and that they want to be 3 to 1. Oops, not 3 to 3, 3 to 1. And then if there are 9 customers in the bank, so we put that in the spot for customers, how many tellers should be available? So we look and we say, well, to go from 3 to 9, we would have multiplied by 3. So 1 times 3 gives me 3 tellers. Solve for x, and then check your solution. So this is more proportions here, and we can do the same thing. And we say, well, to go this direction, notice my arrow is going from the 3 to the 12. I multiply by 4. So again, the arrow's got to go that direction, so 2 times 4 is 8. So 8 twelfths. And then if I divide 8 by 2, divide by 12, oops, by 4, excuse me, divide 12 by 4, I get 8 divided by 4 is 2, 12 divided by 4 is 3. So 8 twelfths equals 2/3. So x equals 8. And then again, to go from here, from the 1 to the 4, I multiply by 4. Go from 5 to the x, then I multiply by 4. 5 times 4 is 20. So I can check, is 4 over 20, does that equal 1/5? Well, both of these can be divided by 4. 4 divided by 4 is 1, 20 divided by 4 is 5. So that one works. Find the area and perimeter of the triangle with vertices 2, 3. So over to the right 2 and then up 3. 5, 3, over to the right 5 and up 3. And then 5, negative 1. So this side of the triangle is 3, this side of the triangle is 4, and the special triangle, Pythagorean triple, is a 3, 4, 5 triangle. We could get that by saying 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16. 9 and 16 is 25, and that would be c squared. So c is 5. So to find the area of a triangle, it's 1/2 the base, 3 times the height, 4. 3 times 4 is 12, and half of that is 6. And since we don't know what the units are, we just say units, and area is always squared. And then perimeter is 3 plus 4 plus 5. 3 plus 4 is 7, plus 5 is 12. And then, again, we don't know what the units are, so we just say units. And perimeter is just plain units. Quadrilaterals ABCD and PQRS are similar. Remember, in similar shapes, the angles corresponding are equal and the side lengths are proportional. So they want to know what is the measure of angle S first. Well, we look in the bigger shape over here and we say what angle would match up with S, and that angle is D. So since D is 80, then S must be 80 if they are similar. What is the length of AD? So we want to know this length right here. And so we look and we say, okay, what side length corresponds to that? And that's 5. So we set up a proportion, and we say that we have 12 to 6. Well, so 12 centimeters in the big one is 6 centimeters in the little one. Those two sides correspond. And the side that we don't know corresponds with 5 centimeters in the little one. So to solve this, we can cross multiply and then divide. That's one way to do it. So 12 times 5 is 60. That's the diagonal. And then divided by 6 is 10 centimeters. So this should be 10 centimeters. Another way to do it is to say that 12 divided by 6 is 2. So whatever the number divided by 5 also has to be 2. And 10 divided by 5 gives me 2. In 9, they want us to expand, and that means use the distributive property. So we have negative 2 times 3x minus, and then negative 2 times 4. Negative 2 times 3 gives me negative 6, because 2 times 3 is 6, and the signs on the negative 2 and the positive 3 are opposite, so my answer is opposite. And then negative 2 times positive 4 gives me negative 8. 2 times 4 is 8. And then it's negative because the signs are opposite. And when I subtract a negative, it's the same thing as adding the opposite. So I can say negative x plus the opposite of 8. Negative 8 is 8. And then factor means what do each of these terms have as a common factor that I can pull out and have it look like the problem in A. So hopefully 21 is divisible by 7, since 7 is a prime number. So I'm going to say it's 7 times x, and then 7 times what gives me 21? 7 times 3 gives me 21. So I can pull that 7 out and have it be outside the parentheses, and then I have x minus 3 left. What is the probability of rolling an odd number on a number cube? How does that compare to the probability of rolling an even number? Well, on a number cube, they're talking about one die, and one die has the numbers 1, 2, 3, 4, 5, and 6. The odd numbers are 1, 3, and 5, so there are 3 out of a total of 6. So the probability of getting an odd number is 3 out of 6, or 1/2. And then the probability of getting an even number, there are also 3 even numbers. So that would be 3 out of 6, or 1/2. So they're the same. Number 11, we are multiplying. So we're going to go from left to right. And we'll say 4 times a half means what is half of negative 4? Well, since a half is positive and 4 is negative, it's going to be half of 4 is 2. And since the signs are opposite, it will be negative. And then we have times negative 3. So negative 2 times negative 3, 2 times 3 is 6. The signs are the same, so our answer is positive. Negative 72xy divided by 6. Since there aren't any variables down here, the only thing that we're going to be dividing is the negative 72 and 6. So 72 divided by 6 is our question. 6 goes into 72 once, twice, so 12 times. 72 divided by 12, or divided by 6 is 12, and since the signs are opposite, then the answer will be negative. So I have negative 12 x, y. In number 13, we have order of operations with fractions. So according to Please Excuse My Dear Aunt Sally, I need to do the multiplication and division first. So when I divide fractions, what it turns into is multiplying by the reciprocal. So 3/4, instead of divided by a half, it's times the reciprocal of 1/2, which is 2/1. And then I can say, well, 2 and 4 can each be divisible by 2. So 2 divided by 2 is 1, whoops, and 4 divided by 2 is 2. So when I rewrite this now, I have 2/3 plus 3/2 times 1/1, which is just 3/2. So then I need to turn these two fractions so that they have a common denominator, and 2 and 3 have a common multiple of 6. So to get 2/3 as something over 6, to go from 3 to 6, I multiply by 2. So 2 times 2 is 4. And then to get 3/2 as something over 6, I multiply by 3. 2 times 3 is 6. 3 times 3 is 9. So I have 4, 6 plus 9, 6, which gives me 13, 6. 4 plus 9 is 13. The 6 stays the same and when you're adding fractions. And 6 goes into 13 twice, and then there's 1 left over. So 2 and 1/6. In number 14, we're again doing order of operations with fractions. So 2/3 times 3/4 comes first before the subtraction. And when I have numbers that are the same diagonal, they can cancel out. So what this really turns into is 1/2 minus 2/4. Well, I know that 2/4 is actually 1/2. So what I have is 1/2 minus 1/2. Anything minus itself is 0. Negative 2 squared means negative 2 times negative 2, which is 4. It's positive 4 because the signs are the same. And then we have negative 2 cubed, which is negative 2 times negative 2 times negative 2. Well, this first set here we know is 4. And then 4 times negative 2, 4 times negative 2 is 8, and it's negative because the signs are opposite. So what we end up with is 4 from the 2 squared and the negative 8 from the negative 2 cubed. 4 times negative 8 is 32, and it's a negative 32 because the signs are opposite. We can do this one a couple of different ways. We can actually write out what they mean. So we have 10 times 10 times 10, that's 10 to the third. And then 10 squared is 10 times 10. And then 10 to the fourth. So anything that matches up, so these ones will all cancel, and we end up with 10 as our final answer. Another way to do that is to use the rules of exponents. So when I'm multiplying things of the same base with exponents, I add them. So this is 10 to the 3 plus 2. So it's 10 to the 5th over 10 to the 4th. And then we can say, well, 10, when I'm dividing things with the same exponent, I subtract. And either way, I get 10. It's a nice thing to be able to check your answer. All right, in number 17, we have 1 2/3 plus 3 3/4 divided by 1 1/2. So the first thing that we need to do, because this is mixed numbers, is we need to turn them into improper fractions. And the way that you do that is you take the big number times the denominator, the whole number times the denominator, and then you add it to the numerator. So 1 times 3 is 3, plus 2 is 5. So that turns into 5/3. 3 times 4 is 12, plus 3 is 15. 1 times 2 is 2, plus 1 is 3. Okay? And now we can deal with this. So we have fractions being divided and added. Division comes first. So we have 5/3 plus 15/4, and then times the reciprocal, 2/3, and 2 divided by 2 is 1, 4 divided by 2 is 2, 15 divided by 3 is 5, 3 divided by 3 is 1. So we end up with 5/3. We haven't done anything with it. And this here is 1, so it's really just plus 5/2. Again, 2 and 6 are going to have a common denominator of 2 and 3 are going to have a common denominator of 6. So we have 5/3 equals something over 6. To go from 3 to 6, I multiply by 2. Do that on the top, and I get 10. And then, oops, 5/2 is something over 2 of 6. Go from 2 to 6, I multiply by 3. Do that on the top, I get 10. Oops, sorry, I get 15. So we have 10/16 is equal to the 5/3, and then 15/16, or 6, excuse me, 6 is equal to the 5/2. 10 plus 15 is 25, keep the 6. 6 goes into 25 4 times, and there's 1 left over. All right. The last one, 64, divided by 0.16. I'm going to do the work over here in the blank spot. There we go. Okay, when you divide by a decimal, you need to move the decimal point over as many times as it takes for it to not be a decimal anymore. And then you match that on the inside one. So our new problem is 6,400 divided by 16. 16 can't go into 6, but it goes into 64 4 times. 4 times 16 is 64. Bring down the 0, 16 can't go into 0. Bring down the other 0, 16 can't go into 0. So 64 divided by 0.16 is 400. Write 1/25 as a decimal and as a percent. So 1/25, the easiest way to do that one as a decimal is to make it over 100 instead. So 1/25 as something over 100. To go from 25 to 100, I multiply by 4. So 1 times 4 is 4. So I have 4 hundredths. So as a decimal, that's 0.0 in the tenths, 4 in the hundredths place. And then 4 hundredths as a percent is 4%. Anything when it's written as 100 that's the percent. The numerator is the percent. Instead of dividing a number by 25, we can simply multiply by any form of 1/25. Show how to use the multiplication and one of the forms of the reciprocal of 25 to find 80 divided by 25. So 80 divided by 25 could be so we have 80 divided by 25, which means, oops, I wrote that wrong. 80 times 1/25 because this would be divided by 25 over 1. You multiply by the reciprocal, it flips it over. So 80 times 1 divided by 25, and then you could turn that into the decimal, 80 times 0.04. 80 times 8 times 4 is 32. And then we ignored, and there's a 0. So 80. We ignored 2 decimal places, so we move it over. So the actual answer is 3.2. Arrange these numbers in order from least to greatest. 12.5 as a decimal, we move it 2 places to the left, so 0.125, and 1/6 is one of them that you should know. It's the decimal 0.16 repeating. And just the 1. We can show that. 1 divided by 6. 6 goes into 10 once. 6 goes into 46 times. And then we'd have 4 again, so it's 0.16, and the 6 is repeating, not the 1. So, the smallest of these is 0.125. The next smallest is 0.15. And then the next smallest is 0.16666, which is 1/6. Draw quadrilateral WXYZ so that sides WX and YZ are parallel and sides XY and YZ are perpendicular. Alright, so let's draw this out. W, X, Y, Z. W, X, and YZ are parallel, means they don't intersect. YZ is longer than WX. draw a quadrant so that x, y, and y, z are perpendicular. So these ones are perpendicular here. And y, z is longer than wx. So this side has to be longer, which would make it come back like that. Just erasing the extras here. So we double check all of our conditions. Wx, which is this side right here, is parallel to yz, this side right here. Okay, the arrows show that they're parallel. xy, which is this side, and yz, which is this side, are perpendicular. And then yz, right here, is longer than wx. And this little angle, they are longer. For problems 22 through 25, find all values of x which make the equation true. So 3 times the absolute value of x equals -6. So -3 times what number would give me -6? Well, 3 times 2 gives me 6, and so this will be 2. So now our question is, which values of x make that statement true? Well, x could either be +2 or -2. And that's how we write that, plus or minus, right on top of each other. It looks like this. X plus x equals 26. So what number, when you add it to itself, gives you 26? That number is 13. And it can't be negative because -13 plus -13 would give me -26. 2x minus 1 equals 19. So 20 minus 1 would give me 19. So 20 has to be equal to 2x. So now 2 times what number gives me 20? 2 times 10 gives me 20. X squared minus 1 equals 24. This number here has to be 25 because 25 minus 1 equals 24. So what number, when you square it, gives you 25? That number is 5. And it could also be -5, because when I square -5, that means -5 times -5, which is +25. So this one is 5 or -5. And again, I could have written plus or minus 5. On a number line, graph the whole numbers less than 5. Whole numbers start at 0. One, two, three, four, 5. Whole numbers less than 5 are 4, 3, 2, 1, and 0. Fritz recorded the daily high temperature in degrees Fahrenheit for a week. Find the mean high temperature for the week. Well, to find the mean, we have to add up all the values. So 81, 78, 79, 74, 70, 77, and 80. So 9, 18, 23, 30, 11, 18, and 10, 18, 25, 32, 39, 46, 54. So now we have 540 when we add them all up, and then we divide by how many there are. and it's a week, so there's 7. 7 doesn't go into 5, but it goes into 54 7 times. 7 times 7 is 49. 54 minus 49 is 5. 7 goes into 57 times. 7 times 7 is 49. Put in decimal. 10. 7 goes into 10 once. 1 times 7 is 7. Bring down a 0. I'm going to run out of room here. 7, 1, 4. 4 times 8, 7 is 28. And we'll just round it then. Just give me 1 sec. I want to check my math on the addition here. Yep. So we're going to call it 77 as our mean temperature. Find the square root of b squared minus 4ac when a is 2, b is negative 5, and c is negative 3. Negative 5 squared is positive 25. Negative 5 times negative 5 is 25, and they're the same sign, so it's positive. 4 times 2 is 8. And then 8 times negative 3 is negative 24. And when we subtract a negative, we can add its opposite. And the opposite of negative 24 is positive 24. Square root of 49 is 7. Both spinners are spun once. What is the sample space of the experiment? Well, on the first spinner, we can either get A or B. On the second spinner, we can get 1, 2, or 3. So we can get A and 1, A and 2, A and 3, or B and 1, B and 2, and B and 3. So the sample space then we get from the table is A1, A2, A3, B1, B2, and B3. What is the probability that the spinners stop on a vowel and an odd number? So the ones that are vowels are A, and the odd numbers with A are A1 and A3. So there are 2 that are vowels with odd numbers, and there are 1, 2, 3, 4, 5, 6 total in the sample space. So 2/6, which is 1/3. In the figure, right triangle ABC is divided into 2 smaller triangles by segment CD. Classify the 3 triangles by sides. So if we look at triangle ABC, it has sides. There's no marking on here to tell us that it's the same length as this side. So we're going to say that this one is scalene. Then we're going to look at triangle BCD. So BCD, this triangle here, and it has 2 sides that are the same. So that's an isosceles triangle. And the last one that we're going to look at is ADC. And it has marks that show that all three of its sides are the same, so that is an equilateral triangle.